the area of the region which consists of all the points satisfying two inequalities are given. One is mod of x minus y plus mod of x plus y less than or equal to 8, and another one is x into y is greater than or equal to 2. Then first we need to identify what is the region bounded by the two independent graphs given, and then once we identify the region, it's very easy to calculate the area. So let's consider the first curve. Modulus of x minus y plus modulus of x plus y is given to be less than or equal to 8. So if you observe both the modulus here, modulus of x minus y can be either plus or minus x minus y. That depends on whether x is more or y is more. And similarly, modulus of x plus y could be with either plus or minus of x plus y. Now, so because of modulus of x minus y can take 1 plus or 1 minus according to the possibilities of x and y, and similarly x plus y also. Then 4 different cases arises out of this. Let's identify what are the 4 cases possible. In the first case, when both x minus y takes a plus sign and x plus y takes a plus sign, then the equation becomes x minus y plus x plus y is less than or equal to 8, or this would give rise to x is less than or equal to 4. Now what do we mean by x is less than or equal to 4? Yes, this is the region which is to the left of the line x equal to 4, right? Now what happens the second case when x minus y is opened with a plus sign but x plus y is opened with a minus sign? Yes, this would now become x minus y minus of x plus y is less than or equal to 8, which in turn gives us y is greater than or equal to minus 4. Now what do we mean by y is greater than or equal to minus 4? Y equal to 4 is a line parallel to x-axis. Y equal to minus 4 is a line parallel to x-axis. So y is greater than minus 4 will give us the region which is above the line y equal to minus 4. Now in the third case, when both x minus y and x plus y takes a negative sign, then minus of x minus y minus of x plus y is less than or equal to 8, which on simplification would give us x is greater than or equal to minus 4. As x equal to minus 4 is a line parallel to y-axis, x is greater than minus 4 gives us a line which is to the right of the line x equal to minus 4. Now similarly the last case when x minus y is opened with a minus sign but x plus y takes a positive sign, then this is minus of x minus y plus x plus y is less than or equal to 8. Now this will result in y less than or equal to 4, as y less than or equal to 4 denotes the region which is below the line y equal to 4. So if you look at all the 4 cases, there are 2 lines which are parallel to y-axis and 2 lines which are parallel to x-axis. So how will be the region for all x and y which satisfies this inequality? Modulus of x minus y plus modulus of x plus y is less than or equal to 8. On the Cartesian plane, the line x equal to 4 is a line which is parallel to y-axis. Then the line y equal to minus 4 is a line parallel to x-axis at 4 units below that of x-axis. And then the line x equal to minus 4 will be a line parallel to x-axis on the left side of y-axis. And then similarly the last line y equal to 4 will be a line parallel to x-axis above that of x-axis. Now what is the region now? This is the line x equal to 4, this is the line x equal to minus 4, and this would be the line y equal to 4, and this will be the line y equal to minus 4. So if you clearly observe, the region bounded by the first inequality modulus of x minus y plus x plus y less than or equal to 8 is, which is a collection of all x comma y such that what is the inequality they are satisfying? Modulus of x minus y plus x plus y is less than or equal to 8 is the region interior to the square formed by what are the lines? X equal to plus or minus 4 and y equal to plus or minus 4. It should be below y equal to 4, above y equal to minus 4, to the right of y equal to minus 4, and to the left of x equal to 4. That means the interior region is the required region, but this is satisfied only by one of them. Now how is the second curve? When we consider R2 to be those points xy, What is inequality satisfied by them? X into y is greater than or equal to 2. This is a region which is easy to identify. X into y equal to 2 is a rectangular hyperbola. So x into y greater than or equal to 2 would be the interior of the rectangular hyperbola x into y equal to 2. Now how will be the curve x into y equal to 2? Yes, it would be in first quadrant or it would be in third quadrant, right? So the region bounded by this is the interior of the rectangular hyperbola. That means this is the portion of the hyperbola for which this point x into y would be greater than or equal to 0. Either the portion interior this side or the portion interior to the rectangular hyperbola this side. So what is the actual area of the region which is required? When we shade the required area, we are talking about this portion of the curve bounded by both the curves, right? Then these are the points which are satisfying both the given inequation simultaneously. Now if you observe this, these two regions are symmetric with respect to origin. In first quadrant the region is same as that of the region in the third quadrant. So can we find out the area in one of the region and multiply that with 2? Yes. So to calculate the area in the first region, we need to identify the points of intersection of these two curves. Now when we talk about the point of intersection, say A, this is the point B and this is the point C. Now how will be the point B? It is the point of intersection of the curves y equal to 2 by x with the line x equal to 4. So can we identify how will be the point B? 1 by 2 comma. How will be the coordinates of B now? It would be 4 comma 1 by 2. Now similarly, how will be the coordinates of A point? That is the point of intersection of y equal to 2 by x with y equal to 4. When y equal to 4, how much is x? It would be half comma 4. So we now know the points A, B and C will have coordinates 4 comma 4. So we know all the three vertices and we need the area included in this. Then the total required area would be twice the area included in one case. Therefore, shall we conclude now that the required area is twice of the area of region in first quadrant. Now, how is the area bounded in the first quadrant? That is area bounded by the line y equal to 4, x equal to 4 with the curve y equal to 2 by x, right? So that would be integral half to 4. The line y equal to 4 is above that of the curve. Therefore, it is 4 minus 2 by x dx, which is twice of 4x minus 2 times ln x measured between half and 4. So what is this value coming up to be? 2 times 16 minus 2 times ln 4 upper limit minus 2 minus 2 times ln half coming as the lower limit. So that is 4 times 7 minus ln 8 or 3 times ln 2, that square units. So this problem, the finding the area is not difficult, but the only problem is to identify the region bounded by the inequalities given. Once we identify the region, finding the area is a simple definite integral. And which option it satisfying? Yes, the option presented A, which says the area is 4 times 7 minus of ln 8 square units is the area, right?